I don't know why it does.
We multiply both sides by this,
And just get rid of it.
and which just gets rid of it altogether,
God.
right?
Yeah.
Because if it's equal to 0, whatever's in the denominator is irrelevant, because to get a fraction equal 0, numerator has to be 0, denominator doesn't matter. So we just divide both sides by it, and it goes away. So we're solving for this now to be 0. Let's see. So
What it's supposed to equal that x thing, or what does the x have that?
that, it says, show that the x-coordinate of this point satisfies the equation that, and that
Okay.
this x-coordinate lies between 3 and 4. So,
Do we plug in?
Are we trying to get it to look like that, maybe, or?
Yeah,
You
that's
know-
I'm confused. Like, why are we?
I think
We're solving.
when we clean this up, it's going to look like this.
Okay, that's
I have it worked out. Sure.
Does it? When you clean this up, does it look like that? Is that what you did?
It should be x equals x plus 1 over ln of x. When if you're going to take the y equals x, take the derivative, set it to 0, then
Okay.
rearrange it so that way it looks like that.
Okay, cool.
Okay.
Perfect, thank you. Alright, so distribute that becomes a 1,
Plus,
right?
Yeah.
X times 1 over x.
Mhm.
And then plus 1 over x minus ln of x, right?
Yes.
So now,
It's
Wait, no, you don't want to do that. You add the ln. I think add the ln
as
To
the
the other
ln,
side.
to the other side.
and then you can divide by it later.
Oh, okay.
okay, ln
Add
of
the
x.
ln and then multiply both sides by x. And
Multiply
then divide
both sides,
divide
yeah.
by the ln. Yeah.
And then divide by the ln.
It's so stupid. It's like you
Okay.
add it over just to move it back.
And then divide. Gotcha. Yeah, that is the part that I never got to because I got cut off and I didn't get to finish it. So there we go.
You forgot an x.
Where?
ln.
Oh, here.
Yep.
And now we're doing iterations, right?
Okay, so now we got that. Yeah, so now we're going to keep plugging in 3 until we die.
Oh, ew.
Right, where's it? Okay. Show that the coordinate. Actually, no. Right, well, that's the next problem. This one, we're going to plug in 3 and 4 and show that there's a sign change. Because that shows it's between 3 and 4.
okay.
Part II says use the iterative formula, gives it to
So we're
us,
still on I.
to determine the x-coordinate. So, yeah, on I, what we want to do is prove it's between those 2 points. Basically, we just plug it in.
So one has to be negative, one has to be positive, right?
Yeah.
So just plug it into the x equation. Okay.
I think we plug it in
Yes. Yes.
3 plus 1 over ln of 3,
Yeah. Yeah.
4
that-
plus
that's-
1
that
over
smells right at least.
ln of 4.
But how would that be a sign
Positive
change?
for that one.
What has to be a sign change?
I don't know, we're going to hope to find out. Does it?
Wait, I wouldn't think so.
I don't.
You wouldn't think so, but then again, it's ln.
The
I don't know
ln
what
is always
that was.
positive, right?
Is that,
They're both positive, I think.
where do you plug it in?
Wait, do you have to put
Is
the
it?
x on
I
the other
believe-
side as 3 too, or do you know what I mean?
As this?
Yeah, do you have to put those?
I
Yeah, you
don't,
should.
Yeah, that's what I was
No.
wondering.
Yeah,
Yeah.
I feel like you should make those 3. and
but we're
then-
not using the iterative formula yet. We're proving that
No, but you're plugging in 3 for x, and since the multiplier equation equals x, then shouldn't you plug in 3 for like the x on the left side? Do you know what I mean?
Yeah, they're both
I
positive.
think we're
But-
supposed to plug it into here, into something that's equal to 0. I just remembered that.
Oh yeah, because we had to do the.
We need to plug it into this.
Yeah.
Oh, okay.
Thank you for not specifying Mr. Murmer.
I remember that.
Yeah.
Okay, so now we plug it into here. So if we plug in 3, we're going to get 4 divided. 4 divided by 3, 4/3 minus ln of 3.
I
So,
don't remember.
someone got it.
I got it. Where was it?
Alright, so this is going to end up being 3 plus 1 times 1 over 3 minus ln of 3, and then also 4 plus 1 times 1 over 4 minus ln of 4. And I'm going to hope that that's a sign change.
That minus. The first one is positive 0.2347. Positive. Then the second one is 4 or 5.
5/4 minus ln of 4.
Yep, it's negative.
Yeah.
Yep.
Alright, we proved it. So now, oh gosh. We got time to start the next one? Determine the x-coordinate.
You got
That's
6
just
minutes.
plugging in, right?
Do you guys know how to do that? Where you just take 3,
right?
plug it into this formula here, you get a number.
And
Take
then
that, plug it back in.
And keep
You know,
doing that until you get the same
until you
thing.
get like 6 of them, until the decimal. You write it out like
Basically-
6 places each
Yeah.
time, and then once the first 4 places are the same,
Alright.
then you get done.
Yeah,
So
I just
do we
know I
need
did
to-
the first
yeah,
part.
that's-
Do we need to do that, or are we good?
That's good.
Okay. Why don't I do that? The chart thing, where you look at it and then you say what you need to.
Yeah, do that.
Okay, so this is something that we came up with at the study group. We're basically, we'll say what you see, if you're going to differentiate it, or if you're going to integrate it.
And
So this is what
the
happened.
upside down cross.
Huh?
In with an upside down cross.
Okay, so basically what you see, if you see something like this, that is the, if you're differentiating it, it's the power rule, right? That's the power rule. If you're integrating, it was called the fundamental law of integration or some weird thing. Do you remember that? Remember
It's
when we first
basically
learned
just-
about integration?
So just
She
like,
said the law of integration? Something like that?
The law of the
The
land.
law of inting.
Law of integration? Something like that? Or we could just call it reverse power rule. If we just call it that, will everyone know what we mean? We
Yeah.
mean the basic integration thing.
You would bring it to the front.
Next one we could see is something like this, where it would be a product rule. So if we're, or it would be 2 things multiplied. If we're differentiating, that is the product rule, right? If we're integrating, that becomes this thing, or we could call this reverse product. You know what I'm saying? Like that's just something we could call it. Yeah, tabular method is the form of that where there's no ln. If we say something like this, differentiating, it would be the quotient rule. But if we're integrating, you would have to do partial fraction decomposition,
Or
right?
Ty's method.
That's what happens when we have. No, that's the other thing. Yeah. So that would be partial fraction composition, or we could call it reverse quotient, where you break it up into the fractions. Remember that, the a over the product and stuff like that we did a few problems of? That's what you do when you need to integrate a fraction, whereas if you need to differentiate a fraction, it's the quotient rule. And then the fourth scenario is
Chain rule, so like
chain rule, so
X.
x to the power of, what was
It'd
the
be like
example?
X plus
Or
one.
it was,
Yeah, X
that's
plus
right.
one.
The example was
Something in parentheses.
x plus 1
Squared to a power.
squared. Here, you would do chain rule if you're differentiating it. But here, you would do u substitution, or that other method that
Ty's
we did, Ty's method.
Y.
I was going to abbreviate it Ty's meth, and then I realized I'm not going to do that. And then, or we could call it reverse chain rule. So basically, this is a chart that says the 4 different types of things you can see, 4 different types of equations. Just a basic x something, 2 x terms being multiplied, being divided, or
Aren't
one
there
within.
like 2 cases of product rule?
I think it's just 2 things being multiplied. There might be something else, but this is usually the 4 basic ones that you're going to see. If you differentiate it, those are the 4 methods that you use. If you integrate, those are the 4 ones
So
respectively.
partial
Well, if
fraction
you-
is the like a plus b or the
Yeah,
VSBC thing.
but what it is when you look at a fraction and you need to integrate a fraction, remember we can't do
Yeah,
that.
it's the
We need to
thing.
break it up and do the ln's individually.
Okay.
So basically, this is what you want to do. If you see this, differentiate it, we just did the quotient rule. These are easy. These are weird different methods that we've been taught, and we finally realized, hey, we each use one of them in a different scenario. So we were like, let's make a chart. So this is the chart that we made.
And we might have to do a second step on the integration of product or the reverse product rule, because we could have another ln situation. In the
Well, yeah, but that's still, this one
Yeah,
keeps
so-
repeating. It's
yeah.
the same method. There's variations of the method, like tons of different details you can go in on partial fraction. That's why we were all taught these, like, from the beginning, But then we had like an individual chapter on each of these things because they're so complicated for integration, because it's undoing a process. So we had to, this is the basic one, but then there's, you have to do a bunch of weird stuff to
So-
basically,
So that one is UV minus
The integral of
dvu. Is
the
it?
integral of dvu.
VDU.
Where would implicit fit here again?
It's like,
Where would implicit fit here?
What?
Implicit.
so anyway,
Is this differentiation?
implicit, that's, if it's a y times